Right, so we're going to talk about IC1, the Introduction to Chemistry unit for 6th grade. How can I smell things from a distance? And this unit is really all about particle nature of matter. So getting students to understand that all matter in our universe is made up of little small particles. But you do not start by telling them that. This is definitely something through experience. They develop their models, their ideas, their concepts. And so this is one of those units where I really want students to develop their understanding and their thinking over time based on the data that they collect and the experiences they have. Your anchoring phenomenon, the very first thing that you're going to do is to start class, and then you can pick a smell of some kind. It can be peppermint, vanilla, or vinegar, but vanilla is probably the most popular one because students actually enjoy that smell as opposed to an unpleasant smell like vinegar. But I put it in a small little beaker, and I put it on a hot plate at the beginning of class, and I have the hot plate turned off. And then as soon as class kind of gets going, I turn on the hot plate because it'll start to emit the smell then. The smell will stay very localized until you turn on the hot plate, and then it really starts to spread through the room. And the idea is that you will have students that are closer to that source, that smell, notice it first. And somebody will say, hey, why does it smell like cookies? Or why does it smell like sweet? Or what's going on? But then some students won't be able to detect it because they're further away from the source. And you want this notion, this idea of like, oh, right, how do we smell things, even though we can't see it, right? It's invisible. You can't see it in the air. And then I always tell a story about like you walk into your house and you can smell what you're going to have for dinner. Like you get this smell in your nose and you know exactly what you're having for dinner. Right? And so this idea that we can, around corners, like you just finished the light unit, the light can't go around corners, right? If there's an object in the way, that blocks it. But that's not true for smell. The smell can go around corners through certain types of surfaces. You can actually get penetrated and into surfaces, like smoke smell can stay in clothing, for example. So what's going on there? And we're trying to this is the whole point of the unit, is like why and how does that work? All right. Now, so that's lesson 1.1. You just kind of get in that. Lesson 1.2 is students draw an initial model. This is a huge modeling unit. Just model upon model upon model. It's really helpful if you can do it digitally. It's not always easy to do it, but it's helpful to do it digitally because then students can just keep adding to their model as opposed to redrawing it every time. However you want to work on that. Some teachers have collected models, made photocopies of them, and then allowed students to keep working on them. But the digital ones are nice because you can delete and all that. So just going to say, I'm going to throw that out there. I never could figure out a system that I liked that it was easy enough for students to use. A few students would do them digitally. Most of them would do hand drawings and then just have to redraw that every time. So just think about that. But 1.2 is asking them to create an initial model of how we smell. So how does that work? What is going on? And they're going to draw all kinds of things, but they need to have the source. Do we have? Yeah, here. This is the image that they get, the sheet that they get on here, and they're going to draw this model. Why is it not letting me? There we go. They're going to get this picture. There's a worksheet you can pass out. So here's the nose. Here's the space between the nose and the source of the smell. What's going on in this little space here that it explains how we're smelling it. Dots are one way that's represented. There's all kinds of ways. So don't get hung up. If they don't use dots, totally fine. It's not necessary. Whoa, I'm all over the place. Sorry about that. Here is example driving question board. If you have not done a driving question board before, I strongly recommend it. It's a really, really nice way for students to see the thinking and the ideas. Lots of these Post-it notes are all about questions, which I didn't talk about yet, but in lesson 1, you should also be having students asking questions about how do we smell. Like, so what questions do they have about smelling and all that stuff. And these go on the driving question board. And then as you go through the unit, you add some evidence or you add some artifacts that show what the concepts that you're talking about in class. This particular driving question board does not have many artifacts. I would strongly recommend including way more. There's lots and lots of cool, interesting labs that you do in this unit. So I strongly recommend that you take pictures of things and post them up on the board. Very, very helpful. All right, so that's lesson 1. We get into lesson 2. And lesson 2, you're looking at does air have mass and volume? That's basically the question there. And you start off with the mass one by taking some sort of sport ball, like a volleyball or a basketball, and having them all deflated, taking the mass of it, inflating it, and then taking the mass again. And that, well, actually, it's probably easier to start with them inflated and then deflate them, have the students deflate them, and then take the mass difference. Find the difference between the two masses. And there is mass there. So we basically know that there's something in air. Even though we can't really feel it, there's got to be something in air because it has mass. And then to test the volume of it, you've got this cool little funnel and flask trick. Probably won't be able to see it very well here. But you put a liquid, food coloring liquid, into a funnel that has another, that goes into this bottle, and then you have this tube coming out, and this is a little clamp right here. And when I don't actually use a clamp, I just put my finger over the end of it, and then I pretend like a dork. I pretend that I'm a magician, and I'm like, I will stop the liquid from flowing through, and I put my finger over the hole here, and then the liquid stops draining. It'll go to a little drip, and then it stops. And then I'll say, oh, I'll make it flow again, and I release my finger, and then it starts to flow, and then I hold it, press it down again, I make it stop, and kind of go back and forth. And then some student is like, we can totally see what you're doing. You're just putting your finger over the hole. And so then we get into the conversation of, well, how does that work? Why doesn't the liquid flow into the container when I have my finger holding over this hole here? And it basically comes down to the fact that air has volume, so that the water can't go in there because there's air in the way, literally in the way. And we think of water being able to go through and past air, but it doesn't. There's a point at which air will hold back water, and so if there's enough pressure, and so air does take up volume. So that gets to that point of like, is the glass half full or glass empty? Well, it turns out it's always full, because it's half full, or half water and half air, but it's always full. All right, unless you're in the vacuum of space, then you wouldn't have any liquid in the beaker anyways. If you were on the moon, I guess there would be liquid in the bottom, but there would be no air in it. Anyways, that's neither here nor there. So that's lesson 2, and then you get into lesson 3, and we start looking at the phases of matter and starting to look at this idea of solid, liquid, and gas, moving between those. They do have some sort of lesson in there about melting ice and then letting it evaporate, and talking about the 3 states of matter for ice. Really pretty boring. Everybody knows that, so I never really do that as a lab. We just maybe talk about it, or I do it as a demo for the students, but that's about it. The cool one is the menthol crystals, and this is the one you do want to do. I think it's 5 grams of menthol on the bottom of a flask like this. You put a glass watch little slide on top with some ice cubes up there. I'll zoom in. And then what happens is that pretty quickly and easily you can see the menthol crystals go from a solid to a liquid, and then you can see the vapor coming up, and it will cool off down here, and it actually condenses around the rim, around the neck of the thing here, and it's got this cool crystal structure to it. It looks really neat. And then the inside of the flask gets all cool looking. It's really a pretty fun activity. Smell is really strong and intense, but it is a cool activity. So really, we're just talking about the 3 different states of matter, and then how does that help us to understand smell then, right? Because we couldn't smell the menthol very well unless we put it next to our nose. As soon as we turn on the hot plate, smell is intense. So there's something about heat and changing state of matter that seem to influence smell, right? We're just trying to create this idea that there's something connected there, which of course there totally is, because that smell is really just little particles of that substance coming off and getting into the air. Even when it's in a solid form, it still does that. Let's see, why does water have so many names? Solid, liquid, gas, vapor, because we use water so much. This is that lab where they melt water. And again, I just kind of skip through it, and I don't spend a lot of time on it. Make this pretty fast. But this is the key part here. This what needs to happen to a material so that I can smell it. And I sometimes talk about cold food versus warm food, right? Cold food you can't really smell very much, but as soon as you warm it up, then you can totally smell it. So there's this heat has a huge effect on it, and of course it's putting those particles into the air so that we can smell it in our nose. But you don't tell students that, you're just giving them the experiences. They should come to that conclusion themselves. Okay, so then lesson 4, we do the modeling activity. Oh, this is the one. 4.1 is what can gases do? So this is kind of looking at what are some of the properties of gases. How do they react? So you got this little hand pump, and there's two places to attach it. There's one right here, and there's one off in the front. One will pull air in, and one will suck air out. And so when you are pushing air in, then you're going to use the hand pump, and you're going to be increasing the amount of air that's going into the pump. You ask students to make predictions. Of course, what happens is that eventually the rubber stopper pops off. They get all excited and think that's super fun. And then the other one is you reverse it. You put the hose on the other side here, and as you're pulling on the trigger, you're sucking air out of the flask, which makes this stopper get pulled in more. And then I have them listen really carefully, and we take off the popper, and you can hear the air suck in. So we know that we can pull air in, or we can pull air out, and we can push air in. And this is a property of air that allows it to expand and contract and do all these things, unlike many other substances. So that's that one. Lesson 5. We get in there. What else can gases do? This is the one I think where we're using syringes. Yeah. So this is the syringe activity. So over here you can see there you have a bunch of syringes with no needles on them, and you have students kind of think about, well, what's the air doing? What does it look like inside the syringe? This is like what they think it looks like inside the syringe. And then if you cover and you put your finger over the edge of the tip here and you press the plunger down, it gets harder and harder and harder and harder, to the point where when you get down to the last little centimeter of space down here, you can't push it anymore. And so you still can't see anything, but you can't push it anymore. So then what's happening to the dots here? How are they compressed all to one side? Really should be just bunches of dots throughout the entire circle, but or at least a higher density than what you see here. And then as you can also pull the plunger out, and then but it wants to pull back in. So as you pull the plunger out, it wants to, if you let go of the plunger, it'll just suck back in. They also really love pulling the plunger all the way out because it makes a really cool little popping sound. Total extra credit for why that makes a sound. That's a really intriguing, fun thing to just talk about. Not that I really know the answer, but it's just fun to talk about. So then students are starting to make these more elaborate models, right? So they're starting to think about, air can expand, it can contract. Many students will use strings, some kind of like squiggly lines to represent air particles instead of the dots. And I strongly recommend that you allow that to be. So as far as we know, they are little dots, but nothing that we collected evidence-wise disproves the string theory. And in fact, when we get down to the quantum level now, there may be some sort of like little strings that are going on in there. So I had a student who was adamant that this must be accepted because we could justify it through all the data, and there was no evidence that we collected that suggested otherwise. And so it was like, absolutely, that's the way it is. It should be something that if it fits the models and the data that we collected, it should stand. And the student was very proud of having their own ideas. Okay. Consensus models, having students work together to make a more in-depth model as you go through. What makes one odor different from the other? So that's the end of learning set 1, right? So just some of the basic properties of air. Learning set 2, you really start digging in on differences. And so you have this lab with ammonia and vinegar, and you are using pH paper to show that they change different colors. So even though they're both clear liquids, even though they both are clear inside the containers, the pH shows up as different. So there's different things that can be detectors that can tell us about the different particles that are actually in the air. It's a computer simulation. You can look at different states of matter, if I remember right. Looking at that. So just a different type of modeling activity. All right, in 7, I did not do the emission spectra of gases. It didn't seem to fit. It works better with the light unit. So if you did anything with emission spectrum from light unit, you could come back and talk about this. But it's kind of a stretch for smell. Doesn't really have anything to do with it. So I didn't do that. What I did spend time on is this reading down here about eNose, the detectors. There are a bunch of videos about dogs that are being used to sniff out cancers and different diseases and things like that, and used for smelling out drugs and for explosives, things like that. So there are all kinds of different ways that noses can work to get information, and everything does put off a different chemical signature. But this is they're starting to talk about the idea of properties, which is going to be really important in 7th grade. So it's important to at least talk about this idea of properties. They talk about hardness and malleability being properties of metals, and there's kind of this weird scratch test activity you have students do, like can one scratch the other, how bendable is one, things like that. Don't have to spend a whole lot of time on this. Again, it's a little bit of a reach, but it does provide some hands-on stuff for students. And you're starting to talk about different elements, right? So these are all pure elements: copper, iron, zinc, can't remember the other one, aluminum is the other one. And so just what each different atom has each different element has a different set of properties. So like different colors, different odors, states of matter, hardness, malleability, things like that. Little introduction into the periodic table of elements. Really don't go into depth in that. Many teachers do a little element project where students get to pick an element totally outside of the standards. Not necessary, but students enjoy it. So if it's something that works well in the timing to keep, if you need something kind of hands-on for the end of a unit or end of a trimester or before a break or something like that, it might be a good idea. All right. A little bit on periodic table. And then 9 is when you start introducing this idea of stick models, ball and stick models of the different elements. And so you can actually, molecules can have this different configuration, basically. And that can be helpful when you're making your models, differentiating between different smells. Typically at this point, we're really just using different colored dots to represent different things, like oxygen, carbon dioxide, the smell, whatever it might be, vanilla smell. So you don't have to go into too much. Not like they're going to draw a bunch of molecular formula in here. Let's see here. So summarizing the ideas of odors in the air. So what does it look like now? What does air look like now that we know that there is not just air, the things we breathe in and out, but there's also this odor that can also fly through the air. All right, then how can a material change so you can smell it is the last learning set. I'm pretty sure this is the last one. And then really this is kind of showing that every different molecule, every different thing that's going to have a different smell is going to have a different molecular arrangement. And that's kind of the bulk of this. So it has them do some activities of smelling a bunch of things. It has them looking at how when you heat up a substance, the particles move faster. So this is basically looking at, I think it's ammonia. If it's cold, it'll turn color very, very slowly. If it's hot, it changes color immediately. It's super, super fast. And so heating up something means that more of those particles are going to be moving up into the air and being detected by your detector. Very important, again, for that diffusion idea, the diffusion model. From the beginning of the unit, why did the students in the front smell it and not the students in the back? Well, because as you heat it up, it starts to move, and that particle has to literally move through the air to get there. So then we get into heating and cooling of substances, and so you put a balloon on top of a flask, and you put it in hot water versus cold water. If you put it in cold water, the balloon will suck into the flask. When you put it in hot water, it expands and it gets big. And so this idea that air is going to expand and contract based on temperature, and that's really important again for 7th grade. Get into weather, talking about why does hot air rise, things like that. But you don't get into that yet. You just talk about, make sure you understand that hot air is expanding, cold air is contracting. All right, and they draw another model of that. So again, lots and lots and lots of models. Bromine, I never had access to bromine, so I never did this before. It's, from what I hear, it's kind of cool because you can see it's solid when it's cooled, and then it starts to get up to room temperature, and then it goes into a gas. But so if you have one of these, great, you can do this lab, or it's really a demo. Otherwise, don't worry about it. Yeah, so then talking about evaporation, again, you go back to this, like, what happens when water boils. So just, doesn't have to be a lab, but you just get them to think about the fact that, like, what's going on here? Why is there condensation on the side of containers, right? There's water in the air and it condenses on a cool surface. You can go into that. Yeah, sweat on the outside of an ice water bottle. All right. And then one of the last activities is taking one of these flasks, and I'm blanking on the name, volumetric flask. It has a line here. Let's see if I can get in there. So you put it, there's a line here for the exact volume. You put it up at that line. That's the starting water level at a certain temperature. You boil it, and you'll see the water expand. So even water expands, not near as much as air does, but it still expands. And you put it in cold water, and you'll see it drops down below the line. And so water can expand and contract with temperature as well as air. And so all substances do that, even solids do that as well, just much less. Yeah, so this is an activity that's done, I think it's repeated every single year in this unit. The idea of hot water, you put food coloring in it, the food coloring quickly spreads out evenly, and cold, it tends to sink and stay, and just a little bit of movement happens. So that way students understand this concept of the molecules are actually moving faster when it's a hotter temperature. And in 7th grade, they'll get into the idea that that's a measurement of kinetic energy. All right, and then, I've never actually did this one before. So I've never done this one with wax, but yeah, so basically at the end here, 15, maybe 16, you're trying to take these models, and you're trying to get back to answer the question, like, how do we smell things from a distance? And so that's what I've always ended with. I've actually never done this mosquito thing. I don't know about this, so I'm not sure about that part. But I've always ended the unit here at 15 is my final assessment, where I talk about how do we smell things from a distance, make models that explain what's going on and how that works. All right, well, hopefully that's a pretty long video there, but hopefully it gives you a good idea of this unit. Super, super, super important video, or unit. This one comes up in every unit from here on out, probably for the rest of their science career. So don't cut any corners on this one. Really take your time. They need these concepts. All right, take care.